Hi, this is the HIM 5113 Lecture 1B for Data Modeling and Structured Query Language in Introduction. If you are not used to report writing tools, or if you have never done any type of programming, I am going to suggest that you dedicate several hours to practicing the SQL tutorial that you will find in this lecture in the w3schools.com website, as well as going out to lynda.com and reviewing some basic information on what structured query language is, what tables and columns are, and some other basic terminology that you may not find familiar as you go through this lecture. Data modeling. When it comes to data modeling, for someone who is an informatics professional, we are going to look at specific areas. You will not become an expert overnight in data modeling, nor should you, as there are roles in information technology organizations that are for data modelers. That's what those people do all day long. They're very good at it. They're experts, they're subject matter experts. From our perspective as an informatics professional, these are the skills and concepts that you need to know as an informatics professional. So we're going to talk about doing a conceptual data model, then using that conceptual data model to create a logical or physical data model or an entity relationship diagram. Technically, these are three separate things, but many times can be interchangeable. And so I'm only looking for you to do one of these. And then we will create a data dictionary. So when we talk about creating or designing a database, we start with a conceptual data model. We need to think in terms of entities and attributes. So let's say we were thinking about an Amazon data model. I'm sure almost everybody has ordered a product online, whether it was from Amazon or Walmart or another store. And so there could be hundreds of tables, but we're going to start simple and we're going to start with 2 or 3 tables. So think about what some of those entities would be. Customer, order, and product are examples of 3 entities. If we were looking at a healthcare database, such as an electronic medical record, we could say that patient, encounter, and visit are examples of 3 entities. In this example of a conceptual data model that I started here, you have an entity called customer and an entity called order. And then we have what the relationship is between the two. So a customer enters an order, or a customer places an order. The word that we have enters between the 2 entities here is really not a big deal. It's just to help you understand the concepts behind the data modeling. Each of these entities eventually becomes a table in the next step. For each of these entities, there are attributes. In terms of a conceptual data model, this is where you start to put down the main attributes. It's not a big deal here if you spell them differently or you have spaces. You may not have all of the attributes. It's just something to help you brainstorm and get started. So if we look at the customer entity, you would have a customer or an account ID, first name, last name, address information, email, and other types of attributes about the customer. And then you would do the same thing for the order. You would have an order ID. What else is an attribute of the order? Well, there's the date that the order was placed. It could be the customer ID that placed the order, the total number of products, the total cost, each product in the order, and so on. Once you have that idea jotted down in a sketch of a conceptual data model, we're going to move on to create more of a logical or physical data model, or what we can call an entity relationship diagram. The ERD is typically what's used to create the database. If we were using database management tools that a database administrator or data modeler would use, we could use the ERD to actually create a script and build out a database. In our case, we're going to use this as a planning document, and then you can actually manually create your small database with 3 tables, and you can do that either in Microsoft Access, or you could do that in a MySQL database if you create a local database that's stored on your own computer. I recommend, if you have not used any database tools before, to go ahead and do this in Microsoft Access. In this example, we have 2 entities that are now tables. We have the customer table and we have the order table. And we have some attributes here. I would say there are probably many more attributes, but let's start with these. And when we say attributes, we can also call these columns or fields. So we have a customer ID, first name, last name, date of birth, and email for the customer table. Next to each column name, we identify which one is a primary key, which identifies the unique identifier for each table. A primary key is typically a code or an ID rather than a free-form value such as a first name. And then we have the data types. And for these first assignments, I don't want you to worry too much about the different data types that are specific to different databases. Instead, let's think about data types in terms of text or string, date, and number. And if a data type is text, we typically jot down the field length, how many characters we would allow. And then we have a relationship here showing the customer ID, which is a primary key in the customer table, with a copy of that field, customer ID, as a foreign key in the order table. Also, the order ID, it's not notated here, and it should, is to have PK next to it, as the order ID would be the primary key for the order table. And in this relationship, we want to say that there's a one-to-many relationship, meaning that each customer or one customer can have many orders in the order table. Next, you'll create a data dictionary, which is a guidebook to explain each attribute or field column in a table and database. Although it may appear obvious, field names are not always obvious. Field names are short, without spaces, and data dictionaries are needed for descriptions of the data, or what we call metadata, which means data about the data. And these data dictionaries can be created in Microsoft Word or Microsoft Excel. SQL stands for Structured Query Language. It's programming code that's used to manipulate data in databases. There are many types of SQL that can do different things, such as extracting data out, editing data that's already in a database, updating or adding new data into a database, or performing transactions. And there are many different types of roles that do this. For this introductory part of SQL, we are going to focus on extracting data. Understanding objects, these are the main objects that you should be familiar with by the end of this module. Tables. A table is the same as an entity. So think about customer. A customer table contains information about the customer. Column. This is what we call the attribute column or field. So first name is in a customer table is a column, as well as last name, date of birth, and email address. Data type. This is the type of data, such as text or number, and different database platforms have different subtypes, such as string or varchar for text, or integer or double for a number. Keys. Each table must have a column noted as the primary key. This column usually contains unique values and does not allow duplicates. The primary key from one table can be linked to the same column placed in another table as a foreign key. Relationships. Relationships are created with primary and foreign keys or when tables are joined together in a query. And there can be a one-to-one, one-to-many, or many-to-many relationship. Queries are simply questions that are asked to the database using structured query language. There is a SQL tutorial from w3schools.com. The link is here, and the link is also within Canvas so that you can easily click on it. As you go through the SQL tutorial, focus during this module on the select and from statements or keywords. Utilize client tools such as MySQL Workbench, which is a free download. Yes, it can be a little clunky and buggy. And you're going to use what we call Open Database Connection. And I have the connection information below. Also, please look at lynda.com, which is accessible from the Temple portal, to look at any short relevant tutorials about SQL. And the W3 Schools resource is the best one. I think it's great to go through it. As one of our assignments, you will go through and do a baseline quiz. You're being graded on whether or not you completed that, not how many you get wrong. But that baseline will give you an idea of where you need to focus in that SQL tutorial. You do not need to know everything that's in that SQL tutorial from an informatics perspective. When you connect to the AHIMA database from MySQL Workbench, or if you prefer a tool of your choice, the connection name can be anything you want to call it. For my connection, I usually just call it the AHIMA database. The host name should be exactly what you see here. The username must be exactly the same. The password must be exactly the same. And the default schema or bucket where you will start out must be exactly the same. And this will also be posted within Canvas so that you can copy and paste it into the connection. Get used to the interface in MySQL Workbench, practice looking at the tables and columns, and then execute some basic select queries using the select and from statements after you complete the W3 Schools tutorial, just those sections that are for selecting columns from tables. And there are many exercises in there. Just focus when you go through the left side of the tutorial, looking at select statements just from one table. And you could start off by selecting either all the columns or just several columns.